So, welcome back. That was a short break, but I hope you had time to recover your energy and attention. So, our next talk it's entitled Persistent User Sessions in RShiny, HTTP only cookies and custom routing. It will be presented by Xavier Escrivá Montagut. Xavier has a background in aerospace engineer, bachelor and master, and then he transitioned to the realm of data science. So, and there he could deep dive in software development and data analysis. In this journey, he pursued a PhD in bioinformatics, and he specialized in developing R packages and Shiny applications, where he can combine his passion for engineer with the intrinsic challenge of bioinformatics. So, without more introduction, the floor is yours, Xavier.
All right. Thank you for the introduction, Oriol. So, as you said, today we'll be talking a little bit about cookies, about routing, and how to implement this all together on a Shine application in order to obtain, well, persistent user sessions. So we'll talk basically about all these topics, hopefully in those 20 minutes. So what was the initial problem that we have? Why did I develop this? So at Bcomics, we have a web platform that is based on RShiny, and on it, you can analyze and visualize RNA-seq data and proteomics data. But in order to access the platform, you always have to use your email to get signed in. That is fine, but if people is using the platform every day, the user experience is not that good. So what we wanted is to users to just log in once and then jump right into the action and start analyzing their data. So how did we manage to do that? Well, we use cookies. And what are cookies, right? Basically, cookies are small pieces of data that get stored on the client computer, that is the user of the application itself. In our case, they are essential for maintaining these sessions logged in or to re-authenticate them on the future when they come back to our application. And it's quite important to notice that we wanted to use especially HTTP only cookies because they are more secure and they prevent or at least lower the risk of cross-site scripting attack risk. Here on your right, you can briefly see how they work more or less. A client, a computer, contacts a server, and the response saves a cookie on the client's computer, which later can be used to re-authenticate the session. As simple as that. And then, how are cookies used? Well, in our case, of course, we are looking at session management, but there are many other uses for them. For example, personalization. Maybe on your web application, you have some settings that instead of saving them on a database in your server, could be saved as a cookie. That's quite good. And also they are widely used for tracking and analytics, which of course then comes as advertising, right? In our case, as I said, we will focus only on session management. Also, to establish a common, let's say, ground for all the people here, we will be talking about routers as well. So what exactly is a router? Well, basically, we can imagine routers as directors that, depending on the path that you are accessing, will show one UI or another. That's, let's say, a very basic definition. As you can see here on the right, if we go to just slash, we see page 1. If we go to slash page 2, we see page 2. This is a very simple Shiny application that it's running as a router. Okay, and we will use them for setting the cookies. You will see in a minute. So how do we do a router in Shiny? I know that there are some packages, but for this application, I wanted to go, let's say, a custom route and not use any already available package and do it myself. In order to do that, there's a very key element, which is the UI pattern argument of the Shiny app function. This argument allows us to put a regular expression, which will basically be checked to allow different paths within our application. And then It's just as simple as checking on your UI function the path that the user has inputted, and depending on it, you return one UI or another. Quite simple. Then, how we set a cookie? Well, when we create an endpoint, we can send a UI or HTML code, or we can return a cookie that will be stored on the client's computer. In our case, we are interested on returning a cookie. Here, as you can see, we check for path/cookie, and if it is that path, we just send a cookie response that we build using the cookies package. As you can see, and as I said before, we can set HTTP-only cookies using this approach. Then, if a user has to access an endpoint to save a cookie, that's very bad for the user experience. We want this to be automatic, and especially we want this to happen through the server. So, for example, when a user gets logged in correctly, we want to save a cookie to remember that user. So, how do we do that? Of course, JavaScript. We need a little bit of custom JavaScript. In much more detail, we just need two pieces of code. One that you see on top is the code that will be sent to the browser. So basically, we are adding a new custom message that is called redirect. And as you can see on the function, it takes an argument called message. This function itself, it's a little bit out of scope of this presentation, but just bear with me about what it does. Basically, it creates a virtual session through JavaScript that contacts the endpoint/cookie. So that sets the cookie. And the good thing is that we can trigger this from the server with the little line that you see below, and we can send whatever value we want to set as a cookie. This is kind of nice because it's totally seamless for the user. So it doesn't have to go to a different tab. The user sees nothing, but the cookie gets set through the server, which is exactly what we wanted. Now, finally, of course, we want to set them, but we are also interested in deleting cookies at some point. So to do that, it's quite simple, as you can see. You create a new endpoint, and you just set the expiration date of your cookie, because of course cookies do expire. And if you set that value negative, then the cookie gets removed. Quite simple. Now, we've talked about how to set cookies within our application, but we are also interested on reading those values because we want to make use of them, of course. So it's also quite simple, actually. We have our session object always on the server of our Shiny applications. And within that object, we actually have all the cookies, all the cookie values. But they are a little bit ugly. Let's say, as you can see below, like it's just one single string separated by semicolons, name of the cookie equals value of the cookie. So we built a very simple, maybe not the prettiest, but it works function, which basically we send the session, we send which cookie do we want, and it returns us the cookie value. Quite simple. And with that, more or less, we have all the ingredients to cook our first application that makes uses of cookies. I've put together a very simple Shiny app to demonstrate everything I've been talking about and how it works. Feel free to scan the QR code or go to the URL to check it out. I've brought not a live demo because it never works, but some screenshots. Here is the toy app. As you can see, we are using the browser DevTools, and we see that there's not a single cookie to be seen. Then, if we click on our button, a cookie appears of the value that we've set it. And it's set it as HTTP only, as we said. And as you can see on the application, this cookie value has appeared. So we can make use of this cookie within our application. And finally, of course, we can remove it, and it gets removed from our browser. Please feel free to play with this application. It's quite simple, but at least it gives a very good, let's say, idea of how everything works. Then, in our case, I've been saying that we want this to be used for session management. That, of course, has some risks attached to it, especially in our case. Like maybe you come up with a different implementation for your own application that doesn't have this risk, but I thought it was interesting to discuss it a little bit. So, in our case, the cookie value that we save is basically the email that has been logged in. And then we check this email, and if it's within our database and so on, it gets authenticated like directly. But of course, we have risk of forgery, because if we saved just the plain email, a user could change that cookie value without a single problem. And then, of course, the user could impersonate a different user. And in our application, each user has their own data. So there were lots of risks about it. So it's quite simple, right? We have to deal with the risk. And of course, the answer is encryption, right? So also, again, to establish super basic common ground, we could do a very quick encryption 101. Basically, when we say we are encrypting something, we are just encoding a piece of information, for example, a string in our case, in such a way that only if you have a certain key, you can understand this information. Of course, this guarantees data confidentiality. Uh, Again, super simple. We could say there are two types. I mean, there are more, but just to establish a common ground, it's okay. We have symmetric encryption, which is using the same key for encrypting and decrypting, and then asymmetric encryption, which uses a pair of keys, one for encrypting and one for decrypting, which is the private one that, let's say, you should not share, to put it in plain words, right? Then, what did we do in our case? Like, discussion about it maybe is a little bit out of topic of about why we chose this, but we went for symmetric encryption using 256-bit shared secret. And good thing is that on R, we have packages for pretty much everything, right? So we have the sodium packages that helps us to encrypt and decrypt strings. Here I've pasted a little bit of the encryption code. So you can see everything using sodium. We encrypt something called email, which of course is an email. And pretty much that's it. Now there's a quite interesting thing about that. All of our code base is actually open sourced, so it's public. And of course, the key that it's within the repository should be changed when you go to production, because if not, everything we've done to prevent forgery, well, it wouldn't be worth it at all, because it could be forged anyway. So that's something to keep in mind when you use encryption within your Shiny applications as well. Be very cautious about where you store the cookie. And well, in our case, you have an encrypted value and a nonce, so we just had to set up two different endpoints. So two different cookies. But that's not a problem at all. And to wrap up a little bit, let's say a little bit of a take-home message. We had a task in hand. We just implemented a custom router, cookie endpoint, and encryption. And just with that, we managed to achieve a successful and secure persistent login of the users. And what is more important, the user experience for our product went through the roof. Like, people used to have to log in every single time. Now they just open our URL and they are good to go. They can start working on the data. So that's fantastic. Now, I also wrote a blog post with more detailed information about all of this procedure, maybe a little bit more code. So feel free to check it out if you'd like. And also, please feel free to check out our platform and see how you like it yourself. And of course, send me an email if you have any doubts or would like to discuss about the work presented here. Thank you very much.
So thank you, Xavier. That has been super clear and didactical. And there's one question from Jessie Rantaya. She asks if cookies could be used to store what selections user has made for the visualizations, so they would persist in new sessions.
Yes, definitely. That would be actually very good approach for our product as well.
Great. So thanks again, Xavier. And yeah, we'll move on to our keynote speak.
Thank you.